All right, guys, so today we are looking at lesson 6-2, which is on operations with functions. So in 6-1, we saw what functions look like in function notation. We saw f of x, h of x, and g of x. And so today we're going to take a look at functions in function notations, and we're going to look at operations with them. So addition, subtraction, multiplication, and division, which is really things that we've seen before. We're just kind of putting it all together with the function notation. So for your essential question, I want you to describe how to evaluate functions that are being added. So for your vocab, we're going to take a look at the operations with the functions. So we're going to define f of x as 3x plus 1 and g of x as x minus 5. And our first operation is going to be addition. So if we were to add together f of x plus g of x, again, we've seen this before. All we're doing is taking the two expressions that those functions have been defined as, and we add them together. So f of x plus g of x would be 3x plus 1 plus g of x, which is x minus 5. So all we would do from there is combine our like terms, and we would have f of x plus g of x. Our next operation is subtraction, and that's f of x minus g of x. So once again, using the same functions that we defined already, this would just be 3x plus 1, which is f of x, minus g of x, which would be x minus 5. Now, notice that I put parentheses around the x minus 5 in this case because we are subtracting it, just like we saw in our polynomials unit. We have to make sure that we distribute that negative to the entire binomial that we are subtracting. So from here, we'd have to distribute that negative to the x and the negative 5, and then we would be able to combine our like terms to get our final answer. For multiplication, that's just f of x times g of x. So again, for these two functions we've defined already, that would be 3x plus 1 times x minus 5. We are multiplying two binomials together, so we would need to break apart our first binomial and double distribute to the second binomial, and that would be the multiplication with functions. And then lastly, just so you can see what division looks like, we're not actually going to do division in this class. If we did f of x divided by g of x, that would be 3x plus 1, 3x plus 1 divided by x minus 5. And that would be f of x divided by g of x. So those are our operations with functions, and we are going to see this with both defined functions, graphs, and tables, similar to what we saw in lesson 6-1. So let's take a look at our guided practice. For GP number 1, we are given three functions that are defined as f of x equal to x squared minus 6x plus 3, g of x is defined as negative x plus 7, and h of x is negative x minus 12. Now make sure you guys are writing toolbox as we go. I'm not going to be listing it specifically for you guys in this unit, so make sure that you're making notes as we go. So first thing we want to do is to rewrite it as f of x minus h of x. So we find f of x, which is here, x squared minus 6x plus 3, and we are subtracting h of x, which is negative x minus 12. Remember, with subtraction, like we just saw in the vocab, we have to make sure to include those parentheses so that we are sure to distribute the negative to both terms in whatever polynomial we are subtracting. So we're going to distribute that negative. That's going to give us a positive x. So I'm going to go ahead and stack our like terms. So a negative negative becomes a positive x, and a negative negative 12 becomes a positive 12. From there, I can go ahead and combine my like terms, and I'm going to end up with x squared. Negative 6 plus 1x is going to give me negative 5x, and 3 plus 12 gives me 15. So that is f of x minus h of x. For part B, we're now looking at f of 2 minus h of 2. So there are two different ways that we can go about this with the evaluating when we have operations. Since we've already combined f of x and h of x, and we've simplified it into this one polynomial, our first option is to take that 2 and to simply substitute it into this polynomial here for the x's. So we're going to look at that. But in the case where we're not asked to first find the f of x minus h of x, what we can do is take f of 2. So we would plug 2 into f of x and h of 2, and we would plug 2 into h of x, and then we would just simply combine what we get from there. So we're going to do both methods so you guys can see what that looks like. So first find f of 2. That's going to be 2 squared minus 6 times 2 plus 3. So this will be 4 minus 12 plus 3, which gives us negative 8 plus 3, which gives us negative 5. For h of 2, that's going to give us negative 2 minus 12, and negative 2 minus 12 gives us negative 14. We are asked to subtract these two. So that's going to be f of 2, which is negative 5, minus h of 2, which is negative 14. Negative 5, that becomes plus 14, and that's going to give us a final answer of positive 9. Now again, because we had already found f of x minus h of x, we can go ahead and plug those numbers in here. So if we plugged in 2 for our x values, that's going to be 2 squared minus 5 times 2 plus 15. 2 squared is 4. That's going to give us a negative 10 in the middle. 4 minus 10 is negative 6, plus 15 gives us a final answer of positive 9 as well. So either way, you're going to yield the same answer as long as your work is correct, whether you choose to plug in for each of the two functions and then combine their answers based on whatever operation we're being asked to use, or if we've already, again, combined those functions with x as our variable, we can simply plug into that polynomial to find our answer. So let's take a look at another one. So first we're asked to find h of x times g of x. So we have h of x here, which is negative x minus 12, times g of x, which is negative x plus 7. We're going to double distribute here, so that's going to be negative x times negative x plus 7 minus 12 times negative x plus 7. We distribute that negative x, so that's going to be a positive x squared minus 7x. Negative 12 times negative x is plus 12x, and negative 12 times a positive 7 is going to give us a negative 84. We combine those, giving us a final answer of x squared plus 5x minus 84. Then we're asked to find h of negative 1 times g of negative 1. Again, our x values are negative 1 here, so we can go ahead and plug those into this polynomial here, or we can plug each of them into the polynomials separately and then combine them by multiplying. So I'm going to go ahead again, because I've already found this polynomial here, I'm going to plug that negative 1 in for my x value. So negative 1 squared plus 5 times negative 1 minus 84 That's a positive 1 minus 5 minus 84. This then simplifies to negative 4 minus 84, which gives us a final answer of negative 88. All right, so that is evaluating functions with operations given each function defined as an equation. So let's take a look at how this will look given graphs and tables. All right, so again, we're given three different functions. F of x defined as x minus 5. We have g of x here defined in a table and h of x defined in a graph. So for part A, we're first asked to find what f of 3 plus h of negative 3 are. So we have two different values of x here. So we're going to start by finding f of 3. So because f of x is an equation, we're going to go ahead and plug our value of x in to find what the value of f of 3 is. So f of 3, plugging in 3 for x, is equal to 3 minus 5. So f of 3, when x is 3, f of x, or f of 3, is equal to negative 2. So x is 3 and y, or f of x, is negative 2. For our function h, we're looking for h of negative 3. So over here we have h of x, so h of negative 3. Here's where x equals negative 3, and our y, or f of x, value is going to be here at 12. So h of negative 3 is equal to 12. We are then asked to add those two functions together. So f of 3 is negative 2 plus h of negative 3, which is 12, and that's going to give us a final answer of 10. Okay, let's then take a look. I'll use a different color here. Take a look at g of 6. So here we have g of x, and g of 6 is equal to negative 6. So we're looking at negative 6 for g of 6 times h of 1. So going over to h of x, looking where x is equal to 1. When x is 1, our y value, or f of x value, is negative 4. So that's going to be negative 6 times negative 4, giving us a final answer of positive 24. So again, over here, h of 1 is equal to negative 4, and up here, g of 4 is equal to, g of 6, excuse me, g of 6 is equal to negative 6. So g of 6, negative 6, times h of 1, negative 4, is equal to 24. All right, lastly, we have g of 4 minus f of 10. G of 4. So g of x is this table here. G of 4 is equal to negative 2. G of 4 equals negative 2. And f of 10. So using our function over here, f of 10, we're replacing that x with 10, is equal to 10 minus 5. So f of 10 is equal to 5. We then subtract those values. So g of 4 is negative 2 minus f of 10, which is 5, gives us a final answer of negative 7. And that is our function notation with operations. using both equations, tables, or using all equations, tables, and graphs. Make sure you answer your essential question.